All right, Algebra 2, this is the CFR1 slash CFR2 last check. We got domain range and end behavior for CFR1, and then we've got characteristics of function graphs for CFR2. Let's go ahead and take a look. Let's go ahead, domains are X values. Well, from here, I don't have an arrow pointing to the left. This means that this function actually stops. So my lowest value is -8. If I was looking at my small x, my biggest, oh, I do have an arrow though. If I kind of decompose the arrow here, I've got some of it going down and some going to the right, which means my biggest is positive infinity. I can write this a couple different ways for my domain. I can say -8 is less than or equal to x, which is less than positive infinity. Or the shorthand way to write this is going to be x is greater than or equal to -8. And that's what I'm going to stick with for now. So in set notation, the set of all numbers in x such that x is greater than or equal to -8. And then interval notation, smallest value is -8, and it could equal, so we put the square bracket around that guy. And then the biggest was positive infinity. Oh, that was a really bad one. There we go. So we've taken care of our 3 different notations for domain. For range, we're looking, do I have an arrow pointing down? Do I have an arrow pointing up? Well, let's look. I do have an arrow pointing down, so my small y is -infinity. I look to see I don't have an arrow pointing up, but I have my biggest value right here, and y is going to be 6. So again, I can write this in 2 different ways. I can say this is from -infinity is less than y. I think it touches, which is less than or equal to 6. And since I think it touches, I'm going to make sure I show that in all 3 notations. Shorthand way to write it, y is less than or equal to 6. For the rest of set notation, the set of all numbers in y such that y is less than or equal to 6. And again, smallest -infinity, biggest positive 6, can be 6. We put the bracket, square bracket, and then we put the parenthesis because it's a -infinity. We don't know that number. And behavior, as x goes to positive infinity, do I have an arrow on the right-hand side? I do, and it's pointing down. So since it's pointing down, my end behavior goes to -infinity on the right-hand side. If I look on the left-hand side, do I have an arrow? No, I don't have an arrow. Since I don't have an arrow, this is an endpoint. X does not go to -infinity. Therefore, my end behavior does not exist, or D and E. Here we go. That's 1 and 2 type level for CFR1. On which intervals is the function increasing? Well, here it's going to increase from -4 to 2. Remember, we're talking about the x values of where it's increasing. So from -4 to 2. And if I'm doing interval notation, make sure I have got some interval stuff going on. That's the only place it's increasing. Whoa, here we go. It's decreasing everywhere else. It's decreasing from -8 to -4. Technically, that is exactly -8. So you could have that. If you just put the parenthesis, I probably wouldn't mark that wrong. For the other part where it's decreasing from x is 2 all the way out. What's all the way out? Positive infinity. There's my increasing and decreasing. Again, going down, going up, going down. Local maximums, again, that's the top of your hill. That is 6 at x equals 2, or you could say 2, 6. Again, this is not an interval. This right here is not an interval. That's a coordinate point. That's a coordinate point. I also have one valley. That valley is right there. Missed right there. That is -5, or that's local minimum. -5 at x equals -4, or you could say -4, -5. Notice the difference. Intervals is interval notation. Intervals. When I'm saying down here, the local maximums and minimums, all I'm asking for there is a coordinate point. X-intercepts, this is just a list. Don't put parentheses around these things. I've got -7 because it touches here, and then -2, and then also here at 5. Don't have to do anything else there. Where is it positive? Where is this function above the x-axis? So from here to here, and here, so from here to here it's positive, and from here to here it's positive. So from -8 to -7, And it is -8 with a square bracket because it's got the got that guy on it. And then also from -2 to 5, it's got that solid dot. And where is it negative? Well, it's below 0 from here to here. Well, down through there. So from here to here, and also from here on. So from -7 to -2, and from 5 to positive infinity. Here, for identifying an interval width, all you're picking 2 different points and then just writing the x values that make it positive, negative, and 0. Well, let's see, if I picked this point and I don't know, this point, if I drew a line between those two things, that would be a positive rate of change. So x is -2 and x is 1. That's an example. -2 to 1, example. Example. -2 to 1. Again, interval means we're looking for x intervals. A negative rate of change, pick 2 points where it's going down. How about that one? And I don't even know that one. So from 3 to 5 in x, that's going down. So 3 to 5. That's, again, just an example. 0 rate of change, the way I like to do this the best, 2 consecutive x-intercepts. So from -7 to -2, if I drew the line between those, that would be a 0 rate of change. Again, just an example. For number 2, I'm just going to put the solutions up. If you got questions, we can take those. Let's see here. Go on to the last one. The last one says, graph the following function with a limited domain. Write the range in the same notation as a domain. This notation right here, that notation is called interval notation. So our range also needs to be an interval notation. This also tells me at -4, I'm going to have an open circle, and at 1, I'm going to have a closed circle. This is going to be a line segment. This is a bounded line segment. So let's see, I know my smallest x value. My smallest x value is -4. My biggest is 1. When I figure this out, I'm going to have a open point wherever -4, whatever the y value is there. And when x is 1, I'm going to have a closed point. So let's figure out what those are. The value of the function when x is -4 is -2 times -4 minus 4, which is 8 minus 4, which is 4. So at -4, 1, 2, 3, 4, +4, 1, 2, 3, 4. That is an open circle. Do the same thing for 1. The value of the function when x is 1, f of 1 equals -2 times 1 minus 4, -6. That becomes 1, 1, 2, 3, 4, 5, 6. And that is a closed point because I had that square bracket. Draw a line better than I'm doing between those 2 points. And that's the graphing part. Now we need to do the range. The smallest value in y is -6. The biggest value in y is 4. From -6 to 4, square bracket around -6 because it has the closed circle, and parenthesis around the 4 because it is an open circle. Again, the problem for number 2, or the part graph number 2, I'll have the solutions up. Ask questions if you got them. The 4 level is going to be me giving you domain range and behavior and some characteristics, and you need to sketch a graph. Hope you're doing well. Take care. Talk to you later.